Assalamualaikum warahmatullahi wabarakatuh. Good day everyone. We are from group 6. We are going to present about index number. Next. Before beginning the presentation, I would like to introduce my members of the group are Afrizi Yolanda, Hijulusna, Fauzia Wendrisa, Jovanka Tiara, and myself, Nur Rahmadani Hamira. Next. So, this is several things that we are going to present. First, price relative. Second, aggregate price indexes. Third, computing and aggregate price indexes from price relative. And then some important price indexes. Then, dividing a series by price indexes. And also price indexes other consideration. And last, quantity indexes. First will be present by me. Price relative. Next. The simplest form of price index represents the comprehension of the current unit price of particular item with the price per unit of the same item in the base period. We can calculate the relative price with the formula price relative in period T equal price in period T divided base period price multiply 100. Next. For example, you can see the reported cost of gallon of regular gasoline from 1994 to 2014 in table 20.1. For its comparison with other years, the actual cost per gallon can be converted into relative price, which represent a percentage of the unit price in each period. Okay, let's take one of the years, namely 2002. The price of gasoline in 2002 is 1.39 divided by the price of gasoline in 1994, which is 1.08 as the base year, and then multiply by 100. Then the price relative is obtained, which is 128.7, where the relative price in 2002 is 128.7 compared to the past year price. Gasoline price increased 28.7%. Next.
Okay, I will explain about the aggregate price index. Number one is unweighted aggregate index. The formula is IP equals to sigma PIT divided by sigma PI0 times 100. For example, next, there is the data for automotive operating expense index. For the question is, find the unweighted aggregate index for this data. Solution is unweighted aggregate price index in period T denoted by IT is given by IT equals to sigma PIT divided by sigma PI0 times 100. Unweighted aggregate index for normal automotive operating expense in 2014. T equals to 2014. To solve the problem, we only need to enter the existing number following the formula as shown, and the final result is 130.1. Next. Number 2 is weighted aggregate index. The formula is IP equals to sigma PIT times QI divided by sigma PI0 times QI times 100. For example, next, still using the same data and there are annual usage information for automotive operating expense index. For question is, find the weighted aggregate index for this data. Answer, to solve the problem, we also just follow the formula with the data provided, and the result is 223.3. Next. In a special case of the fixed weight aggregate index, the quantities are determined from base year usage. In this case, we write Qi equals to Qi0 with the zero subscript indicating base year quantity weight, the previous formula becomes IP equals to sigma PIP times QI0 divided by sigma PI0 times QI0 times 100. Next. We will conclude that the price of automotive operating expense has increased 123.3% over the period from 1994 to 2014. In different uses, a weighted price index can provide a better comparison. Whenever a fixed weight number is determined through use of the base year, the weighted total index will be called the last year's index. Another way to determine the weight of a quantity is to change the quantity of each period. A quantity, QIP, is determined for each year that the index is computed. The weighted aggregate index in period T with this quantity weight is given by IP equals to sigma PIP times QIP divided by sigma PI0 times QIP times 100. This weighted aggregate index is known as the Passer index. Okay, that's all from me, and thank you.
Next is computing an aggregate price index from price relative. Next. In section price relative, we define the concept of a price relative and show how a price relative can be computed with knowledge of the current period unit price and the best period unit price. Now, we want to show how aggregate price index like the one developed in section aggregate price index can be computed directly from information about the price relative of each item in the group. Because of the limit use of unweighted index, we restrict our interaction to weight aggregate price index. This is example for price relative. Here, we can calculate the price relative, and the formula is price in period T divided base period price multiplied 100. For example, gallon of gasoline. The value of 3.44 divide 1.08, and the result is 380.5. Next is example for automotive operating expense index decide on wage price relative. We get the wage with the formula PO multiplied T, and the formula wage price relative is price relative multiplied 100 multiplied wage. The last, we can calculate the wage aggregate price index in period 2040 is the total wage price relative divided total wage, and the result is 223.3. The index number 2023.3 represent 123.3 increase in automotive operating expense. Next.
The next is some important price indexes. We identify the procedure used to compute price indexes for single item or group of items. Now let us consider some price indexes that are important measure of business and economic condition. First is Consumer Price Index. The CPI is a weighted aggregate price index with fixed weight. The CPI includes charge for service and all taxes directly associated with the purchase and use of an item. Second, Producer Price Index. The PPI is designed as a measure of price change for domestic goods. Import are not included. The PPI is based on price for the first transaction of each product in non-retail market. All commodities sold in commercial transaction in this market are represented. Next. And last price index is Dow Jones Average. The Dow Jones Average are indexes designed to show price trend and movement associated with common stock. DGEA components are chosen from all the major sectors of the economy, with the exception of the transportation and utilities industry. Stock from this sector are covered by the DGTA and DGUA. Next topic, deflating a series by price indexes. This time series often show an increasing growth pattern over time, which is generally interpreted as indicating an increase in the physical volume associated with the activities. Time series are deflated to remove the effect of inflation. These concepts are based on the notion of deflating an hourly wage index. This process of deflating a series measure over time has an important application in the computation of the gross domestic product or GDP. Next. For the example, we see a trend of wage increases from $24.91 per hour to $26.21 per hour. Should electricians be pleased with this growth in hourly wages? The answer depends on what happened to the purchasing power of their wages. If we can compare the purchasing power of the $24.91 per hourly wage in 2010 with the purchasing power of the $26.21 hourly wage in 2014, we will be better able to judge the relative improvement in wages.
Next, price indexes, other consideration. First, selection of item. The primary purpose of a price index is to measure the price change over time, classified by class of item, product, and so on. For example, in the consumer price index, the total number of items that might be considered in the population of normal purchase item for a consumer could be 2,000 or more. Next, selection of base period. Most indexes are established with a base period value of 100 at some specific point. All future values of the index are then related to the base period value. For example, a consumer price index with a 1945 base period would be difficult for most individuals to understand because of unfamiliarity with condition in 1945. The base period for most indexes, therefore, is adjusted periodically to a more recent period. The PPI currently uses 1982 as its base period. Next, quality change. The purpose of a price index is to measure change in price over time. Ideally, price data are collected for the same set of items at several times and then the index is computed. For example, a manufacturer might alter the quality of a product by using less expensive material, fewer features, and so on from year to year. The price may go up in following years, but the price is for a lower quality product. Next, quantity indexes. In addition to the price indexes, describe the preceding section, other types of indexes are useful. In particular, one other application of index number is to measure change in quantity level of quantity index. To compute an index number for period T, we need data on unit price at a base period and period T. This is the formula. Next, the quantities are weighted by a fixed price, the value added, or some other factor. Value added to product is the sale value minus the cost of purchased input. The formula is IT equal to sigma key ITWI divided by sigma key I0 WI times 100. In some quantity indexes, the weighted for item I is taken to be the base period price, in which case the weighted aggregate quantity index is IT equal to sigma key IT PI0 divided by
sigma Ki0 Pi0 times 100. Next, quantity indexes can also be computed on the basis of weighted quantity relative. This formula is the quantitative version of the weighted price relative formula. Industrial Production Index, developed by the Federal Reserve Board, is probably the best known quantity index. It is reported monthly and the best period is 2012. Thank you.
Okay, thank you, Joe. So that's all from our presentation in which is about index number. Sorry for every mistake that we make. Thank you for attention. Assalamualaikum warahmatullahi wabarakatuh and bye-bye.